Hey guys, welcome back to the shop. Frank here. The project I'm working on now is an upgrade to the mini dozer. I pulled the dozer here into the shop, and 2 episodes ago, I guess, I drilled the bolt circles in the new sprockets. I'll walk over here. So I've got 2 new sprockets. I kept calling them gears in that video. I don't know why. Anyway, got two new sprockets with the 5 lug on 4.5 inch circle drilled, and they're prepped. Now those 2 sprockets are the same as the existing drive sprockets on this tractor. Let's go to the front here on the right. So, yeah, I can't get you in there. I don't know if you can see, but there's a sprocket here. This is this sprocket drives this track. This transmission on the front is a hydrostatic transmission, and this side drives, the other side freewheels. And this was in the design of this tractor. On this side, the rear has a sprocket. You can see a sprocket here. And this transmission on the rear is hydrostatic, and this side drives the other side freewheels. So that's how the 2 tracks operate independently on this tractor. And if you want to see the build in more detail, there's a whole series on the channel of how I modified the Cub Cadet transmissions so that they would drive in forward and reverse at the same speed. I modified the swash plates in those transmissions. Then I welded the spiders and put bushings instead of splines on the freewheel axles. So I basically made them one side only, positive drive, right side for the front and left side for the rear. There was some discussion about, one being the front, one being the back, but to be honest with you, on this thing, I can't tell any difference between whether it's driven in the front or the back. And most dozers that don't have the high wheel design, just have the 2 lower drive, have drive in the back, and they go forward and backwards, so they can move both directions. The newer tractors with the high wheel design have the drive up here. So and that's to get it out of the dirt, really. And the newer ones are all hydrostatic drives, and they have 2 hydrostatic motors, 1 on each side. So in my opinion, for this build, it didn't matter whether it was front or rear wheel drive. Having one on the front and the other side on the rear hasn't made any difference that I can tell. So the project is to swap out these 2 idlers here and here for sprockets. And assuming that works okay, I'll come back and do the other side as well. So we'll have a sprocket up here, which is the drive sprocket, and then 2 idler sprockets. Since the 2 sprockets don't drive, they freewheel. These 2 back here will freewheel. They'll go to whatever position is necessary to properly engage the chain. So it doesn't matter. There's no risk of binding. So and I think a commenter during the build made that observation. So we're going to swap them out for sprockets. I'm hoping the sprockets will give a little more, a little smoother operation than these idlers. So we'll see about that. All right, we're going to get started. Got to take this apart. I'm not sure the best way to do it, so we may fiddle with it a little bit, but we'll get going on it. That worked pretty well. So I got a chance to use my forklift again. Pick the track up off the sprocket. So at least I will work on this sprocket first. So I'm sliding the leg shield. It bolts to the bottom there. I've slid it forward, and this will give me access to the back side of the wheel, idler wheel assembly. So I can undo the clip and pull the axle. Yep. What do you think about that? All right, so here's the idler. Get it up on the bench here. All right, so we need to mount the sprocket inside here. And we do have the proper bolt circle here. All right, let's see about taking this apart. All right, so we want to wind up with the same stack up, the same dimensions as this assembly, but we want the sprocket to be in the middle. Let's see roughly what the distance is. 3.035. Three, 2.993. So basically 3 inches. So that's where we need to be. All right, so let's measure the sprocket. I think it's about 7/8. Let's see. Yeah, 0.871, just under 7/8. So 7/8, this is a quarter, this is a quarter. So inch and 3/8. That's a quarter. That's a quarter. All right, so I need to complete a 3-inch thick setup here with the sprocket in the middle, and the distance between the outsides of these two plates is 3 inches. The sprocket is 7/8. So, and these two are each a quarter of an inch. So 7/8 plus a quarter is plus a half is 1 3/8, 1.375. 3 minus 1.375 is what? 1.625. 1/5/8. I need to cut that in half, so half of that is what? 0.8125, which is 0.125, so that's 13/16. So just over 3/4. Just over 3/4. So we need to have a spacer of about 3/4 or 13/16 on each side of the sprocket. So someone suggested I get a air over hydraulic jack for this, which is such a good idea now. Almost bought one. They had it on sale at Harbor Freight, I think. And I said, well, I don't use the press that much. And also need to do something about this valve, make it easier to operate. All right, so I think we can just use it as a spacer and through bolt it. So that only took less than 10 minutes. All right, so my plan here, I don't want to just set this on a couple of parallels and then try to grab it with the two jaws of the vise. So I'm going to clamp it. Oh, look who's here. My little brew. My buddy. How you doing? Huh? You being a good boy today? That's my brew. That's my brew. Where's my Butchie? Where's Butchie? Where'd Butchie go? There he is. There he is. Oh. Okay. You be good boys. All right. Gotta give them a little bit of loving. So I've decided to clamp this in the vise by bolting it to a couple of 1, 2, 3 blocks, and then I'll clamp them in the vise. So I don't need super accuracy here. I would not say this is accurate enough setup, though it may be fine actually, but we'll see what we get here, how this works out. I think this will work. As long as the spacer disc is flat on the vise jaws, it'll be fine. I left the screws a little loose so that these 1, 2, 3 blocks can conform to the jaws. Give it a little tappy tap tap tap. All right. So my target, these are 1 inch thick. My target is 13/16 or close. That's solid. So I'm measuring these spacers at slightly under an inch, 0.985, 0.984, 0.983, so we'll call it 0.985, 0.984. So we want to get down to 0.8125, 13/16. So that means, looks like that's, my calculation is right, 0.1725. So 0.1725 depth of cut. So we've got a 2-inch face mill here. I get to bring the knee up to set my depth of cut. Let's see. Zero out the quill DRO right there. So I've got the depth of cut set here on the quill to 0.09, basically half of the depth of cut we need. Alright, so we'll increase the depth of cut to 0.17. Three. $725. Okay. Cleaning up the back side of that cut. Okay. Let's see where we wound up, if I can get my calipers in there somewhere. .818. I want .8125. .822. .818. That's plenty close. Can't get a good measurement on it unless I deburr it and pull it out of the vise the way it's sitting. All right, let's mount the other one, mill the other one. A lot of chips in these holes. All right, let's see where we are. I was shooting for .8125. I've got 81, 812, 812 right there, 813. .813. So I would say that's pretty close. .812 right there. I think that worked great. Let's see how close are. All right, so when I come down and touch that, my quill DRO says .0015, so that's within a thousandths, 1.5 thousandths. That's pretty close for repeatable setup as far as that's concerned. Okay, so let's go back and set it to the same depth of cut, basically half of the, all right, that's .09, half of the required depth of cut, and start up the VFD. That's that high-pitched whine is the VFD making a noise. Kind of annoying, but should mount the VFD someplace else so I don't have to listen to it. That would be a good idea, wouldn't it? All right. Cutter clears. Let's see how we did on this one. .81. .812, .81, .8, yeah, .812, pretty close. All right, so I would say we got to our desired. I'm going to deburr this, and then we'll go back and assemble our idler sprocket assembly. Look who's come back in. There's Butchie. You guys are being, it's so hot outside. So, it's good boys. Okay, I've got most of the chips cleaned up here. Actually, all the chips cleaned up. So floor's clean. And you'll notice in the, in this building, in this shop, I keep the floors clean. I like it being tidy, but I also protect the dogs. So. All right, we're right 3.01, so right at the 3-inch target. Yep, 3.010, 3.015. So we've got our sprocket installed in the wheel. Get the wheel back on the, let's put the wheel back on the tractor. Let's just test it with the chain. This is a piece of the chain, so it fits in there fine. Okay. Get this mounted. We got a spacer here. Okay, I got it on this shaft. Let's get the so you can see the shaft here goes through the bearing, through to a spacer collar, the collar on the wheel, and then comes through the other side, collar on the wheel, spacer collar, and then this bearing. And I've got the shaft all the way to the start of the bearing. These two pins. All right, got the one there. And the one up here. So there we go. All right, guys, we're going to wrap this one up at this point. We've got the high wheel sprocket idler installed. We'll come back next time replacing the lower one here on the rear. We'll take this brace off, and the wheel should come off with 5 lug nuts. Pretty easy. We'll need to separate this track a little bit and pull it back so we have clearance to remove the wheel. But that shouldn't be a big deal now that we've got the technique mastered with the forklift. So thanks for watching. Leave a comment, thumbs up, subscribe if you haven't already. Would appreciate it. It'd help the channel a lot. Help the YouTube algorithm a good bit. All right, we'll see you guys on the next one.